Good morning, students. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so today we'll start the first unit and topic number one, civil engineering, its history and the recent breakthroughs in civil engineering. So my subject is civil engineering, societal and global impact, Hsmc 252. So this is your first lecture and the first topic of this unit. So let us first know what is civil engineering. So civil engineering, it is a professional engineering discipline and it basically deals with design, construction and maintenance of physical and naturally built environment. And this naturally and physically built environment basically involves public works such as roads, bridges, dams, airports, canals, sewage systems, pipelines, structural components of buildings and railways. So civil engineering is the oldest form of engineering subdiscipline and it is also second oldest in terms of military engineering. So it is basically defined to distinguish between non-military engineering from the military engineering. History of civil engineering. So in 18th century, the term civil engineering was coined. And the first self-proclaimed civil engineer was John Smeaton. You have to remember this name, John Smeaton. He constructed the Eddystone Lighthouse, and in 1771, Smeaton and some of his colleagues formed the Smeatonian Society of Civil Engineers. So, Smeatonian Society of Civil Engineers was a group of leaders of the same profession, that is, civil engineers. And how they formed the society, they met informally over dinner for a casual dinner, and there and then they decided to form this society, the Smeatonian Society of Civil Engineers. Though there was some evidence of technical meetings of the society, but those information is very less. Next, in 1818, the Institution of Civil Engineers was found in London, and in 1820, the eminent engineer Thomas Telford, remember this name, he became its first president. The institution then received a royal charter in 1828, formally recognizing civil engineering as a profession. So the charter definition for civil engineering is mentioned below. This definition is very important, and this definition you have to write it exactly the same way because it is a chartered or rather a coined definition and you can't change its words and placement of words. So the definition is the art of directing the great sources of power in nature for the use and convenience of man as the means of production and of traffic in states, both for external and internal trade as applied in the construction of roads, bridges, aqueducts, canals, river navigation and docks for internal intercourse and exchange, and in the construction of ports, harbors, moles, breakwaters and lighthouses also, and also in the art of navigation by artificial power for the purposes of commerce and in the construction and application of machinery and in the drainage of cities and towns. The next topic is recent breakthroughs in civil engineering and its innovation. So the world's production industries have already generated tremendous amounts of economic growth, but industrialization of cities has also led to significant changes. So these significant changes includes overcrowding and extreme pollution. So because urban environments are often home to many industrial facilities, people come to the city seeking employment. That we all know, but large metropolitan hubs are running out of space to house their residents. So with overcrowding, resource demands are also increased, and because cities grow, urban environments may also face more pressure in their attempts to provide large urban populations with sustainable supportive infrastructure. So what is the sustainable supportive infrastructure? This includes food, water and safe roads. So advanced civil engineers are needed now more than ever to provide solutions to these critical issues. So civil engineers use innovation to improve building materials and construction methods. This is the main and basic role of any civil engineer. So for example, engineers are creating technologies to give buildings healing abilities and schemes. Engineers are also developing technologies that reduce the environmental load of the structure, which is important. So here I have cited several developing innovations. These are currently being used around the world in order to improve the socio-environmental sustainability. The first one is plastic roads. So related to these innovations, there are 5 or 6 innovations. So related to this innovation, I'll be showing you, after this lecture, I'll be showing you short videos so that you can understand better about these innovations and their definitions also. So the first one is plastic roads. So in response to massive generated local waste and plastic pollution in countries, India's government, in our country, India's government began experimenting with plastic roads, and this happened during the early 2000s. This happened with the help of waste plastic, which is being used as a construction material. An early report of India's Central Pollution Control Board discovered that even after 4 years of use, the Jambulingam Street in Chennai, this street is at Chennai, it is one of the first plastic roads in India, and it had not sustained much damage even after a year by using plastic waste. So the board cited that no potholes, rutting, raveling or edge flows were discovered during the inspection or evaluation. So this level of performance attracted the local governments. So who were looking to get rid of Tamil Nadu's urban environments discarded shopping bags, foaming packaging and other unrecyclable plastic products that were disposed in the streets. So as of 2015, any Indian city with a population of at least 5 lakhs is required to construct their roads using waste plastic as the core material. This was formulated in 2015 after seeing the use of the waste plastic in Jambulingam Street in Chennai. So this is made in effort to promote greater pollution control and environmental sustainability for our Indian communities, basically to reduce pollution. So although the concept of using waste plastic in roads, it is still in its early stages, with very few plastic roads currently existing in the Western world. But civil engineering researchers are in countries are like United Kingdom and United States are continuously working to design new technologies to support the safe implementation of waste plastic in road construction. So one such development involves converting waste plastics into small balls that, when combined with asphalt or other common road components, creates a strong permeable surface that features hollow spaces that allow stormwater to seep through the road and more effectively reach groundwater. So transitioning to the use of plastic roads, it will lead to more manageable plastic waste and potentially more safer roads. But there are still some concerns regarding hazards that accompany plastic roads as they age. So as these roads gradually deteriorate due to heat and light, which is very much common and obvious, they may dissolve into microplastics that gives off harmful pollutants and that will finally affect the functionality and biodiversity of soil and water resources. Creative civil engineers play a significant role in ensuring that the science behind using waste plastic for roads is accurate or rather perfect, and that future iterations of this concept are carried out with a consideration for environmental health and safety. The next innovation is green roof systems. The Environmental Protection Agency, in short EPA, it defines green roof as a vegetative layer grown on a rooftop. Today, green roof systems have become popular all over the world. And it has become popular not only for their beauty but also for the benefits they provide towards environmental sustainability. Germany is currently leading the world in green roof technologies, and they have implemented green roofing systems on approximately 10% of their German homes since the technology emerged in the early 1970s. So civil engineers are responsible for ensuring that a green roof supportive infrastructure, for example, a comprehensive watering system, is engineered to consistently deliver an appropriate amount of resources, and the roof itself must be designed to effectively provide working improvements to environmental sustainability. However, civil engineers still face some obstacles when planning the installation, maintenance of green roof systems like high cost and harsh climates, but innovations in modern engineering techniques for green roofing systems have allowed the industry to consistently offer the following environmental benefits to urban communities. Next, so the environmental benefits that the urban communities get using green roof system is mentioned here in 4 points. The first one is enhanced urban biodiversity. These 4 points are very important, so you need to remember this. The first one is enhanced urban biodiversity. Green roof systems accommodate new flora which may act as new habitats for different species of plants and animals. Number two, cooling of buildings. The vegetation of the roof or on the roof acts as thermal insulation, storing excess heat and decreasing peak temperatures within the building. So this means basically less energy must be consumed to heat the building, resulting in decreased energy cost and lower pollutant emissions. Number three, reduce runoff quantity. On average, green roof retains 40 to 60% of total rainfall. So storing this rainwater as it falls has been shown to result in runoff reduction of 34% between September and February and 67% between March and August. So by reducing runoff, civil engineers that design green roof systems can limit strain on sewage systems and mitigate the cost or lessen the cost of roof damage. The last one, pollution control. Green roofs are composed of plants that absorb nitrogen, lead, zinc, and airborne pollutants like carbon dioxide. This absorption also reduces the negative effects of acid rain by raising the pH values of acid rainwater before it becomes runoff water. Next, eco-floating homes. Affordable housing and overcrowding in cities are putting much pressure on urban populations, as I have mentioned earlier itself, and to make changes. So to combat or to overcome these issues of overcrowding, civil engineers are designing floating homes, practical living spaces that sit upon the water or rather that floats upon the water. So the homes are designed to resist floods by floating on top of water using a foundation of concrete and styrofoam, which makes them virtually unsinkable. So this approach means that homes can be built in spaces that were previously off limits, like rivers, lakes, and other water bodies. Civil engineers predict that modern flowing home technology will lower the cost of flood damage in urban cities while also providing compact inner city populations with more diverse housing options. Next, vertical farming. So using multi-story high-rises to grow food is known as vertical farming. And the Association for Vertical Farming has found that when comparing with traditional agricultural methods, growing food indoors uses 98% less water, which is very good, and 70% less fertilizer, which is much better on average. To generate the amount of light and water necessary to keep plants healthy, while remaining as cost effective as possible, that also should be kept in mind, the cost effective. Vertical farmers use a combination of energy efficient LED lights and hydroponic technology. About LED lights, we'll study in our upcoming lectures. Hydroponic technology includes plumbing, irrigation, and filtration. So by implementing this modern automation or automatic techniques to regulate these systems here refers to the vertical farming. Civil engineers can also limit the cost of labor required to maintain these farms. So the costs associated with vertical farming are still quite high, but as science in this field advances, civil engineers will be able to provide the populations of unfarmable regions with opportunities to grow their own nature produce. Hence, many entrepreneurs and scientists are currently evaluating or surveying how growing food inside a building coincides with improving social and environmental sustainability, how it helps the population socially and also environmentally. Vertical farms also have higher yields than traditional farms, allowing the production of more food using far less urban space. Hence, significant process in the study of vertical farming could lead to improved food diversity, especially for residents of population dense urban areas and in places that are normally unable to grow produce using traditional methods. The last one is rainwater harvesting. So harvesting rainwater is a climate adaptation strategy, and it has been used in ancient and modern societies. So the antiquated rainwater harvesting techniques of the past, those were basically attempts to cope up with the severe climate conditions by storing the water as it fell, allowing populations to drink the water or prevent oversaturation of the land during extreme precipitation. So modern rainwater harvesting is fundamentally the same in theory, but advancements in science and engineering have introduced sophisticated filtration and rain capturing technologies that boost the efficiency of the process. Dutch engineers and researchers are using effective large-scale implementation on rainwater harvesting infrastructure, which reduces stormwater runoff by 20 to 50%. By mitigating or lowering the strain that excess storm precipitation usually places on sewers and drainage of systems. So this is made possible by mounting rainwater catchment devices on the roofs of buildings, then routing the rainwater that is collected by the catchment through a treatment system and then finally into the storage tank. So in order to ensure the effectiveness of this rainwater harvesting, the contents of each storage tank must be depleted before significant rainfall events occur. Therefore, civil engineers must obtain the knowledge and also the necessary experience to analyze the precipitation patterns and water usage rates of a region before installing any rainwater harvesting systems. So, with cost-effective approaches to the catchment, storage, and filtration technology used in rainwater harvesting currently being implemented and improved, larger scale rainwater collection is poised to become a widely used, economically viable solution to urban potable water shortages and stormwater management. So large cities have come up with many social benefits, but there will always be disadvantages to having large populations that are constricted to a finite amount of space or restricted to a finite amount of space. So ensuring that humans can live sustainably in highly populated urban environments, it requires creative solutions to infrastructural issues like safety, road safety, housing crisis, and food and water shortages. So any advanced degree in civil engineering will provide an individual with an in-depth understanding of the environmental, structural, and infrastructural components having engineering knowledge required to work with the civil engineering innovations that were listed or that were stated above. So this is your weekly assignment. You have to explain the different disciplines of civil engineering. This one I already showed the video in our first class itself. So based on that, this question has been given to you. Last date of submission is mentioned here, 29 April, which is Thursday. And if you have any doubts or queries, you can contact me. But please don't send me personal WhatsApp messages. You can if you have any doubts, you can send in the WhatsApp group, our subject WhatsApp group. So now we'll go through videos. So this is all for this lecture.
Ma'am, hello.
Yeah, hello. You can give your attendance in
Can you
the.
share?
Yes, tell me.
Can you share your PPT in the WhatsApp group, ma'am?
Yeah, I will share that.
Today's, yeah.
Yes,
Okay.
yes, I'll share. And you, everyone, please give your attendance in the chat box. Do mention your name.
Ma'am, no audio.
Mostly in cities, have you ever experienced an intensive heat and poor air quality inside and outside your house? then this technique will definitely be one of your solutions. Let me introduce myself. My name is Vinay, and if you are visiting my channel for the first time, don't forget to subscribe my channel. Also, click the bell icon. Let's start a video. So, what is green roof? A green roof is a layer of vegetation planted over a waterproofing system that is installed on the top of a flat or slightly sloped roof. Green roofs are also known as vegetative or eco friendly roofs. They fall into three main categories: extensive, intensive, and semi intensive. Although there are no precise definitions of them, an extensive green roof has shallow growing medium, usually less than 6 inches. These grow up to only 6 inches with a modest roof load, limited plant diversity, minimal water requirements, and is often not accessible. And next, intensive green roofs have more soil and a deeper growing medium, sometimes several feet, that can support a more diverse plant sections, including small trees. Thus, they have more substantial structural loads and need more frequent maintenance and watering, usually accessible. Semi-intensive green roofs include features of both types. The appropriate depth of any green roof depends on the roof structure, the plan chosen, annual rainfall, and stormwater performance requirements. And there is also other type of green roof, that is modular green roof. Some green roofs are installed in one large integrated sections, while modular green roofs use some portable planting beds placed together to create a large green roof. The modular units are often plastic or metal trays filled with growing medium. Modular green roofs can be installed incrementally and can easily removed for maintenance and inspection of the roof layers underneath. One drawback, however, is that moisture cannot flow between units, increasing the impacts of wet and dry spells on the plants. Next, we talk about layers of green roof. All three types of roofs require specific layers of roofing material not found on regular roofs. The basic anatomy of a green roof consists of vegetation, roof media, filter membrane, drainage layer, waterproof or root repellent layer, roofing membrane support for planting above, thermal insulation, vapor control layer, and structural roof support. Each of these layers perform a specific function to keep the plants alive and to protect the structure beneath. So we discussed definition, types, and layers of the green roof. Now we talk about advantages and disadvantages. First, advantages. These improve drainage system and these also increase the lifespan of the roof. Green roofs boost the thermal performance and these also help out the environment in many ways. These also support wildlife habitats and green roofs also increases air quality. The main disadvantages of green roof is that these green roofs are expensive than the traditional roofs, but worthwhile in the long-term use because this saves energy and helps the environment. The other disadvantage is that the dead load due to green roofs increase on the structure and these require extra maintenance. These roofing systems are used in some countries, but in India, these are very expensive. The government should give incentives for who install these green roofs. Thank you for watching the video. If you like our video, please give a thumbs up and don't forget to subscribe.
I've grown up on the water. We've probably built, it's amazing, 50, 60 homes on the river. We build floating homes in Portland, Oregon. My father got out of the Navy and decided to start building homes. And I was just at that age where just a little too antsy to stay in college and decided to kind of follow that path. We get a lot of calls from all over the country. There's not a lot of guys that do what we do. And believe me, I would love to do other areas, but this is where we have our facility, all of our guys. We don't travel.